So for this question is another explanation question. So we are trying to show that the line intersects the curve at 2 points. So the 2 points is representing two roots. So your job is to show two roots. So your job is to show that the discriminant is always positive. So this is the objective. So in order to show, okay, you will need to execute again your simultaneous equation first. So you will have the straight line and you will have the curve. So if you would like to execute the showing, so you need to get your ABC so that you can execute the showing. So if there is a straight line and a curve, it will come from simultaneous. So the purpose of the simultaneous is for you to find the value of your ABC. So sometimes some of you may have careless mistake in the simultaneous in your ABC. So in the end, you couldn't prove. So your job is to show discriminant positive. Do not start with discriminant positive. So I'm going to find the expression first. So I'm going to find the expression. So that involves a little bit of algebra expansion. So after my algebra expansion, you will realize that you actually get a quadratic function. So what can you do with this quadratic function? So you can do a complete square. Do a complete square. So this is your expression for the discriminant. So this is the expression for the discriminant. Okay. From the expression of the discriminant, you got to deduce that it will be always positive. So the explanation part lies on the square. So anything that is squared is always positive. So if you add on 64 on both sides, that means, right, the discriminant. So you deduce that the value of the discriminant will be more than or equal to 64. So from here, the interpretation is the value of the discriminant is 64 or more. So in a way, the discriminant will always be positive. And when the discriminant is always positive, the indication will be there are two roots. So therefore, the line intersects the curve at 2 points. So this is one of the very common techniques. If your discriminant is not a value, it is a quadratic expression, you can always go for a complete square. So in fact, right, from here, we can also do a direct way to get to this. So I can do something like this. I can factorize out a negative. So when I factorize out a negative, you square the -1 in the bracket. So you also get the same answer as if you complete square. So you can choose to expand out and do a complete square, or you can do this alternative. It's up to you. Whatever is it, when you have a complete square, when something is being squared, it is always positive. So this is the explanation of how do you show two distinct intersection.